Hello guys, welcome to Exam List, and this lecture series is all about advanced classical mechanics. In the advanced classical mechanics, our main aim will be understanding the Lagrangian formulation and how we can use the calculus of variation in deriving the Lagrangian formulation, and we'll talk a little bit about Hamiltonian formulation in the end. But to understand the advanced classical mechanics, we need to understand some prerequisite. One of the most important thing that you need to understand is the radius vector, how to work with the radius vector, and then we'll talk about center of mass, concept of reduced mass, some prerequisite that will help you understand the advanced classical mechanics. So let us start our discussion. So consider, um, so what is radius? Okay, radius vector. So vector represents position. For example, consider this 1D. In 1D, you always need to select an origin, and say in 1D you have this particular place called as P. Agreed? So from here to here, consider the distance is say R. So since it is in 1D, so let us take X. So the P can be written as also X vector. It represents the position of point P. Agreed? So x vector can be what? So x vector can be any value. Say here x vector is 5 centimeter, but this 5 centimeter is just magnitude of x. Okay, so there has to be something called as direction of x. So direction of x seems to be towards the east. So let me write E for east. Agreed? Similarly, we can have 2D. Okay, in 2D, I mean when you consider two coordinate system, one is x, another is y. Agreed? So consider this is the y coordinate and this is the x coordinate. Now consider a particle is somewhere around here. The particle is at point P. Then this particle is represented from the origin by a radius vector, and this radius vector contains all the information regarding the position of particle P. Now you will ask how. So consider this radius vector is represented by r vector. Agreed? We know that every r vector can be written in terms of the x and y coordinate. One is x coordinate xi, another is y coordinate yj. Agreed? So it indirectly, so once you know the r vector of point P, then you know along x-axis where it is and along y-axis where it is. For example, this point P is at a distance say x, and this side the distance is say y. So to make it more clear, let me give a dotted line from here to here, and let me give a dotted line from here to here. Agreed? So r vector actually represents the position of any point P on a 2D coordinate system. Now consider if I move this point P from here to another new point P dash. Agreed? So let us see. So now we'll talk about the displacement of particle. Okay, so again consider the two coordinate system, one with the y-axis, another with the x-axis. So this is point P. Initially point P had a radius vector say r. Okay, so this radius vector is say r vector, and now the point P, say it goes from P to a new place, say P dash. Agreed? So what about P dash? P dash will have its own radius vector. So from here to here, and this can be represented by a vector line. As I said, vector represents the position of points, and say this P dash is represented by a vector R dash. Agreed? Now if somebody asks you what is the displacement of P, then the displacement of P is written by a vector del R. Del r means from P to P dash. The distance from P to P dash is given by del r vector. And in the vectorial notation, it is written as r dash vector minus r vector. Agreed? So this is delta r, this part. The green line here is delta r, and delta r represents the displacement in terms of radius vector r. Now, what is the meaning of delta r? See, delta r can have two components. One in this side, say this is delta x. The blue line here is delta x, and another can be towards upper side. So there is another component of delta r, say this dotted line, and say this is delta y. So delta r vector has two components. One is the delta x in the I cap, and another is delta y in the j cap. Agreed? What does this mean? It means that if you look at this carefully, this delta x is actually towards the other side. I mean, there should be a minus sign for convenience, because you see the value of p. So initially the p was at position say x. Now the p is at position, the x coordinate of p is at x minus delta x. So you see, when p goes from p to p dash, it means on the x direction we went from x to x minus x dash. It means the value of x coordinate decreased. And we can see that the value of y coordinate has actually increased. So initially the p had the y coordinate y, and finally p dash has the y coordinate y plus delta y. It means that when p goes from p to p dash, the x coordinate has decreased and the y coordinate has increased. Now these are all vectorial notation. These are all vectorial notation. If somebody asks you what is the length of delta r, then to calculate the length of delta r, you need to do the magnitude. So that will be, once you know the del x, then you have to do del x square plus del y square. Agreed? So what does this mean? This means that now you have actually calculated the length of delta r. See, as I said in our lectures, vector notation is just a symbolic representation of things, but just from vector notation you cannot calculate the entire length of vectors. To calculate the length of vectors, you need to find the geometry. Okay, that geometry means you need to find the magnitude. So in this way you can calculate. So if somebody asks you what is the length of r vector, so p is represented, you can see p point is represented by r vector. Like somebody asks you what is the radius, what is the actual distance of point P from origin, then the actual distance of point P from origin is root over of x square plus y square. It is quite natural because point P has x coordinate in this direction and point P has y coordinate in this direction, and by Pythagoras theorem one can easily find out the radius length of radius vector P. Now p dash is represented by what? P dash is represented by r vector. Now what is this r dash vector? Now what is this r dash vector? The r dash vector, if you look at it clearly, is actually x minus delta x square. This is the x coordinate of r dash, and what is the y coordinate of r dash? Y plus delta y. Agreed? So let us try to solve this. Let us see what do we get when we solve this. So let me delete this part. Okay. And so our main aim is to solve p. So p dash. So what is p dash now? So p dash is equals to, So r dash, okay, and the magnitude of r dash, I mean the length of r dash is, so this is what, this is length of r dash. So let us do the straightforward calculation. So you will get an x square and you'll get a 2x delta x, and you'll get a delta x square which can be ignored because it's very small. Second, you'll get a y square and you get a 2y delta y. Agreed? So now if you can look at this formulation clearly, you'll find something interesting. Now what you do is just keep it aside, and let us do one thing, that is, okay, let us write all the terms, let us not ignore the terms. Okay, so let me also write what are the two extra terms. There will be a delta x square and there will be a delta y square. Okay, so this is my r dash. Now if you look at another relation, so what was our initial relation? We know that the delta r vector can be written as r dash vector minus r vector. Agreed? So what will be r dash vector? So r dash vector can be written as delta r vector plus r vector. Okay, now what is the magnitude of r dash? The magnitude of r dash will be root over of delta r square plus r square. Agreed? So what is root over of, so what is delta r square? So you can look at from here. So delta r square will be delta x square plus delta y square. So it will be delta x square plus delta y square. And what is r square? You know r square is x square plus y square. Okay, we made a mistake, so let me rectify a little bit. So this part, just forget this part. Okay, this part you need to forget. So because we're getting the wrong answer, so try to look at this part. So from here, so you know what is delta r dash. So delta r dash is del x in the I cap direction and del y in the j cap direction. Great. And now what is r? R was x in the I direction and y in the jth direction. So what happens now? Bring the I together. Now one thing you need to remember, that del x is del r is actually minus delta x. As I've stated earlier, the minus sign is because there has been a decrease in the distance. So bring I together, so you get an x minus delta x I, and you get a y plus delta y j. Agreed? So what is this? This is our r dash vector. Now if you expand this vector, how to find the magnitude of r? So you can easily find the magnitude of r as root over of x minus delta x square. Okay, and what is the second one? Second one will be y plus delta y square. So again you see you got the same thing. You got the same thing. A little bit of mistake in the upper part. So here there will be a minus sign. Great. There will be a minus sign. Anyways, so let us take a quick review. Okay, so let me just take a quick review. Okay, so quick revision. One, We moved a particle from P to P dash. So in vectorial notation, the delta r, that is the displacement of the particle, is r dash minus r. This is in the vectorial notation. Now if somebody asks you what is the length of r dash, what is the length of r, and what is the length of delta r? 1. The length of delta r can be found out by using this formula, because delta r is itself minus delta xi plus delta y j. You can look at from here directly that the delta r here has two components. One in the y component, that is delta y, and another component is in the delta x. So whenever a vector has two components, you can easily state their length. So this is part 1. Part 2 is, if somebody asks you the length of r, you can easily say the length of r is root over of x square plus y square, because you can see from here r has two components, x and y. What do you mean by r? By r, I mean the point P. Now, if somebody asks you what is the length of P dash, then you can easily see that P dash has two components. One is x minus x dash, and another component is y plus y dash. And since we know that these are the two components of r dash, one can easily find the length of r dash by using this formula. Remember, this is length of r dash. So now once these things are done, question is what have we done here? Now here what I wanted to explain to you is that this formula gives us the correct result of the length of r dash. That is what I wanted to prove. Now how did I prove? So I have written r dash in terms of delta r and r. This is still in the vectorial notation, and this, the next step is writing delta r and r in terms of their vectorial notation. So this part is also in the vectorial notation. But as I said earlier, once you know the vectorial notation, you can easily state the length. Here I have found out length. By collecting the I together, I have written still in the vectorial notation that the I component of r dash is x minus x dash, and the j component of r dash is y plus y dash. So the same information that we initially derived using the geometry, here we used geometry. We looked at x, we looked at y, we looked at delta x and delta y, we looked at the p, and we geometrically we saw what p will be. The x-axis of the p dash will be x minus x dash, that we saw geometrically because we draw diagrams here about the length and everything. Okay, so what we saw geometrically has been proved mathematically also. So this is the length of r dash mathematically. Okay, I know it has been a little bit of complicated discussion, but please review this lecture again, listen to this lecture again, and things will be clear. Okay, so in conclusion, what I want to say, okay, let me wrap the entire discussion. So what I want to say here is this: we have two things at hand. One, we have a vector, and another, we have a length of vector which is given by the mod of the vector. Okay, so when a particular point P has a vector r and the point P is displaced to a new point P dash and the vector is r dash, then in vectorial form the distance from P to P dash is actually r dash minus r. This is in vectorial form. Now consider r has two component xi and yi. So I can write r as xi dash in the I direction and y dash in the j direction. And I can also state my r as x in the I direction and y in the j direction. Agreed? Now if I collect my x and y, what will I get? I get x dash minus x in the I direction, and I get a y dash minus y in the j direction. Now all of you know that x dash minus x will give rise to the change in the x coordinate in the I direction, and the second one will be change in the y coordinate in the j direction. So again I proved that. So let me draw the diagram here. So you had two axes. So from here, from these two axes, um, from the origin, one distance is the r vector and another distance is the r dash vector, and this distance from p to p dash, okay, this distance is your delta r vector. So this is delta r vector in terms of the coordinate, in terms of the Cartesian coordinate. Remember, this is still in the vector form. To calculate the length of delta r, what you can do is you can do the you can take the mod of delta r that we have already done in our last lecture. So as I stated that r dash has two coordinate x dash and y dash, and p has two coordinate x and y. Okay, now when you went from p to p dash, there has been a decrease in x because you see the p got shifted in this direction. Okay, the new p dash is here, so the y x coordinate has got shifted in the negative direction. So that's why I said that x dash minus x will be not delta x but minus delta x. Why? Because x is greater than x dash. Look at it here. The x is somewhere around here, and the x coordinate of p dash, that is x dash, is somewhere around here. Therefore there is a minus sign, and you can look in the shift. So when the particle went from p to p dash, the shift in the y direction is given as this is the shift in the y direction, and the new coordinate is y dash and the old coordinate was y. So what is the shift in the y direction? The shift in the y direction is y dash minus y, that is your delta y. Agreed? So these are various ways of writing vectors in terms of components and then solving them. Okay, so these things will be more clear when we look at our further discussion on center of mass. So to understand center of mass, the understanding of radius vector was quite important. So we'll continue our lecture in the next class.